Okay, I am here to describe the free radical halogenation reaction in organic chemistry. This is, the same reaction that you see usually in the organic chemistry 1 course, as well as for the same reaction that you would see for the MCAT or for the DAT or whatever exam it is that you need to take. Basically, I'm not an organic chemist or a chemistry major. I'm an engineer, so you know this and a little bit more advanced. This is really what I get into. I always remember this by saying in my mind free radical halogenation, free radical halogenation, free radical halogenation. That way, when I see free radical, I immediately think that I'm going to be halogenating something. So I'm going to be putting in a halogen group to adding it to something. I'm going to be halogenating that, whatever it is. So in this case, in this free radical halogenation, we're going to be halogenating an alkane. Alright, so here I have my alkyl group bonded to a hydrogen, which is an alkane, plus molecular halogen. So I have it as an X bonded to another X, reacted with heat or light, basically with energy, will create an alkyl halide. So thereby I have halogenated the alkane, and a byproduct will be an acid which will have which will be the hydrogen, the original hydrogen bonded to one of the halogen molecules, atoms. All right, so the mechanism of an alkyl halogenation, of a free radical halogenation, has 3 steps. Has a step number 1, it's going to be the initiation step. Step number 2 is going to be the propagation step, and step number 3 is going to be the termination step. Initiation step alone, it involves the reaction of the molecular halogen with light or heat to monolithically cleave the molecular halogen, the halogen molecule, into 2 halogen radicals. All right. So heat or light will be monolithically cleaving the halogen molecule into 2 halogen radicals. Monolithic cleavage means that something will be cleaved in such a way that one of the components of that bond will retain one of the electrons, and the other one will retain the other electron. Okay, so that is monolithic cleavage, and that is the way that radicals are formed. Alright, so now we've covered the initiation step, which is the making of the halogen radicals, which are the ones that are going to be crashing into the other molecules, making the reaction propagate. Now that I've monolithically cleaved this molecular halogen into halogen radicals, I go into the propagation step. So the propagation step involves one of the radicals that I've monolithically obtained, out of my monolithic cleavage, plus the alkane that you're originally planning on halogenating. All right, so that is part of the original of the overall reaction. So this halogen radical will crash into the alkane molecule and will cause monolithic cleavage of this alkene molecule as well, and the halogen molecule will actually bond to one of the hydrogens, to one of the hydrogens. It actually breaks a carbon-hydrogen bond in this molecule, and that hydrogen will bond to the halogen and will yield an alkyl radical. All right. So the halogen radical crashing into the alkene molecule will generate acid, which is the alkyl radical with one of the hydrogens, and where the hydrogen was abstracted from is going to leave an alkyl radical. All right. I always think of the propagation step as having two sub-steps. All right. So this is this is sub-step number A. I'm going to call it A. All right, for propagation, and this is sub-step B for propagation as well. So now the alkyl radical that was left from that reaction is going to come in here, and it's going to crash into the halogen, into the molecular halogen molecule that's also present in the solution, and it's going to crash into that molecule, and it's going to cause homolytic cleavage of that halogen molecule. Again, just as light or heat did here. Now instead of light and heat, I'm gonna be crashing it with the alkyl radical, and I will, and just as in this step, this alkyl radical will abstract one of these halogens and will bond to it, as you can see here, and is going to leave an alkyl radical, just as light and heat left alkyl radicals in here. Okay, I mean left halogen radicals in here, and that halogen radical that was left is gonna come in and is gonna keep doing the same thing. So now we have the halogen radical right here. Now we can think of putting it back in this step and doing the same thing, having it crash with, you know, other molecules of alkane, you know, doing the same thing, then generating an alkyl radical in an acid. Then this alkyl radical again goes here and monolytically cleaves another molecular halogen molecule and does the same thing. And that's all over again until all the reactants are consumed. Once there is no more alkane to be made, basically, the reaction goes into the termination step. The termination step, I've numbered it here, step number 3. There is many different ways of this termination. There is 3 different ways I would think of this termination step to occur. But what you have to remember is that it occurs in exactly the same way. Termination step involves the combination of 2 radicals into a product. Okay, 2 radicals or whatever. So what I did is I went ahead and with my green marker, I marked all the radicals that I've generated in the whole reaction. So in the first step, I've generated radicals of halogen radicals. And then in the second step, I went ahead and generated radicals of alkyl radicals. And really what I have here is only alkyl radicals and halogen radicals. So in whichever way these radicals can combine will cause termination. So the first way is having all my halogen radicals combining together and just forming my molecular halogen again, right? Just like it is here. So I have halogen radicals combining, forming a halogen, a molecular halogen again, all right? Or my halogen radical combining with an alkyl radical, forming the product that I'm expecting to obtain, which is an alkyl halide, right? So I have it right here. My halogen radical, my halogen radical bonding to an alkyl radical, forming an alkyl halide, or the other possibility is my alkyl radicals bonding together to form another alkane. All right. So notice that in the termination step, the only way a termination step that a termination step can occur is by combining 2 radicals. So if they ask you the question, which of this of the following reactions involves the termination step, and you see 2 radicals in the reactant side, immediately you know that's the answer. All right. So 2 radicals combining to form a product. So I have 2 radicals of halogen forming molecular halogen. 2 radicals, 1 radical is going to be a halogen radical and an alkyl radical forming an alkyl halide. See? 2 radicals forming an alkyl halide, or two alkyl radicals forming an alkane. Alright? Two radicals, one product, two radicals, one product, two radicals, one product. That is the way I think of free radical halogenation. Again, free radical halogenation is the way I call it. I think of it in my head in one sentence, free radical halogenation, because I know I will be halogenating something. Real quick review before we go. Free radical halogenation. In free radical halogenation, we're going to be combining a molecular halogen with an alkane using heat or light to form an alkyl halide and a byproduct, which is going to be an acid. Alright, the mechanism is 3 steps: an initiation step, a propagation step, and a termination step. Initiation step is where you react only the molecular halogen part of it with light and heat, and light or heat monolithically cleaves the molecular halogen into two halogen radicals. Monolithic cleavage is the type of is a type of breaking a bond. Is how you break a bond where each one of the species retains one electron forming two radicals. That is monolithic cleavage. All right. So now that I've formed two alkyl radicals, I go into two halogen radicals. I go into the propagation step. Propagation step, I think of it in 2 substeps. Substep A, substep B. Substep A is where the halogen radical crashes into my alkane, right, from the original reaction, my alkane molecule, and this halogen radical takes one of the hydrogens, forming an acid, leaving an alkyl radical. This alkyl radical goes here to substep B, and it monolithically cleaves a molecular halogen bond, just like in the first step, but now without heat. Instead of heat or light, we're using the alkyl radical to monolithically cleave this bond. Then this reaction forms an alkyl halide and another halogen radical, just like we did in the first step. So now this can go back here and do exactly the same thing, go here and end up here. And then it can do it over and over again until all the reactants are consumed. Once the reactants are about to get all consumed, we go into the termination step. Termination step involves the combination of 2 radicals to form one product. Okay, 2 radicals to form one product. Notice that in the initiation step, we have a molecular halogen and light and heat. In the propagation step, we have 1 radical and something that's not, in a molecule, 1 radical in a molecule going into products. In the termination step, however, we have 2 radicals on the left-hand side and a product on the right-hand side. 2 radicals, so what I did is I said, okay, all of the radicals that are formed, all types of radicals, are really formed 2 types, okay? If they 2 combine, in whichever way is combined, it's going to cause termination of the reaction. So, if I combine 2 halogen radicals into a molecular halogen, it terminates my reaction. If I combine a halogen radical with an alkyl radical to form an alkyl halide, which is really what I'm looking for, it's going to end the reaction. And if I combine 2 alkyl radicals together to form a big alkane, it's going to terminate my reaction as well. So notice, 2 radicals, 1 product, 2 radicals, 1 product, 2 radicals, 1 product involves the termination step. So this is free radical halogenations. Thanks for watching.